Deep in the most desolate, frozen corner of our planet lies a sight so jarring that it looks like a scene from a horror film. In the McMurdo dry valleys of Antarctica, emerging from the pristine white face of the Taylor Glacier, is a waterfall of vivid, arterial red. For over a century, explorers and scientists have looked at this blood falls with a mix of awe and confusion. It doesn't freeze, it doesn't stop, and it looks exactly like the glacier is bleeding into the ice-covered Lake Bonny below. But as we move through 2026, new research into the depths of the Antarctic ice has revealed that this isn't just a geological oddity, it is a portal to an ancient world. The secrets of Antarctica's blood falls are finally being mapped, revealing a pressurized subglacial lake that has been sealed off from the rest of the Earth for millions of years, containing a form of microbial life that shouldn't be able to exist. When the Australian geologist Griffith Taylor first discovered the falls in 1911, he assumed the red color was caused by a rare type of red algae. It was a logical guess. Antarctica is home to many unique extremophiles. However, as the decades passed and chemical analysis became more sophisticated, the algae theory was debunked. There was no plant life in the water. Instead, the liquid was found to be a hyper-salty brine, 4 times saltier than the ocean. The red color, as it turns out, is a result of a massive chemical reaction. The water emerging from the glacier is packed with iron-rich saltwater. While it is trapped deep inside the glacier, the water is clear because it is deprived of oxygen. But the moment it hits the Antarctic air, the iron reacts with the oxygen in a process known as oxidation. It is, quite literally, instantaneous rust. The glacier isn't bleeding, it is rusting on contact with the atmosphere. This explains the color, but it doesn't explain how liquid water can exist in a place where the temperature rarely rises above freezing, or where that water has been hiding for eons. The most significant 2026 update in the study of Antarctica's blood falls comes from the use of radio echo sounding, RES. By sending radar waves deep into the Taylor Glacier, scientists have mapped a massive pressurized subglacial lake hidden several miles beneath the ice. This isn't just a small pocket of water. It is a sprawling, ancient reservoir that has been trapped since the Pleistocene epoch, between 1.5 and 4 million years ago. The reason this water remains liquid at temperatures well below zero is twofold. First, the extreme salt content lowers the freezing point of the water significantly. Second, the massive weight of the glacier above creates immense pressure, which generates heat through a process called latent heat of freezing. As a small amount of water freezes, it releases energy that keeps the rest of the brine in a liquid state. This lake is essentially a pressurized balloon of ancient seawater trapped inside a mountain of ice. Periodically, the pressure becomes too great, and the glacier erupts, forcing the iron-rich saltwater out through tiny fissures in the ice, creating the sporadic flow of the blood falls. The most mind-blowing aspect of the 2026 findings isn't the geology, but the biology. The water in the subglacial lake is a perfect time capsule. It has been sealed off from the Earth's atmosphere, sunlight, and the rest of the biosphere for millions of years. There is zero oxygen and zero light. Under these conditions, life as we know it should be impossible. Yet when scientists sampled the brine, they discovered a thriving community of microbial life. These bacteria have evolved a way to survive that is unlike almost anything else on Earth. Instead of using photosynthesis, which requires light, or aerobic respiration, which requires oxygen, these microbes have hacked the chemical environment of the lake. They survive by breaking down sulfates and using the iron in the water as a catalyst to breathe. They are essentially eating the minerals of the Earth to stay alive. This ecosystem has remained stable and isolated for millions of years, evolving in total darkness, proving that life can find a way to thrive in even the most hostile alien environments. The study of Antarctica's blood falls in 2026 has massive implications for astrobiology, the search for life on other planets. If a community of microbial life can survive for millions of years in a pressurized, lightless, oxygen-free lake beneath miles of Antarctic ice, it changes how we look at places like Mars or Jupiter's moon, Europa. Mars is known to have iron-rich soil and subsurface ice. Many scientists believe that beneath the Martian permafrost, there could be pockets of hypersaline brine very similar to what we see at the Taylor Glacier. Similarly, Europa and Saturn's moon, Enceladus, are known to have massive subsurface oceans hidden beneath thick, icy crusts. The blood falls serves as a terrestrial analog, a laboratory right here on Earth where we can study how life might function in the oceans of the outer solar system. By understanding the metabolic secrets of the Antarctic microbes, we are essentially writing the field manual for what to look for when we eventually send probes to drill into the ice of other worlds. In 2026, the research teams at McMurdo are deploying ice-fin robots, slender, torpedo-like submersibles, designed to swim through the narrow fissures of the glacier to reach the subglacial lake directly. These robots are equipped with 2026-grade chemical sensors and microcameras that are giving us our first ever visual look at the interior of this ancient reservoir. What we are finding is a world that is chemically distinct from our own. The levels of dissolved gases and the specific isotopes of the minerals suggest that this water hasn't touched the outside world since humans were just beginning to walk upright. The iron-rich salt water isn't just a byproduct, it is the lifeblood of an entire hidden world. This 2026 exploration is teaching us that the surface of the Earth is only a small part of the story. There are vast, hidden biospheres beneath our feet and beneath the ice that we are only just beginning to map. Antarctica's blood falls is a reminder that the Earth still holds mysteries that can shock us. What looks like a scene of macabre violence is actually a sign of life's incredible resilience. It is a story of iron, salt, and survival against all odds. What do you think is the most incredible part of this discovery? Is it the idea of a 2-million-year-old time capsule hidden under the ice? Or the fact that this might be exactly what life looks like on Mars? I'd love to hear your theories in the comments. The alien life discussion is always one of my favorites. If you enjoyed this deep dive into the science of the Taylor Glacier and the mystery of microbial life, please give this video a like. It really helps the channel grow and allows us to keep bringing you these stories from the edges of science. And if you're new here, make sure to subscribe and hit that notification bell. We're tracking the biggest discoveries of 2026 across every continent and beyond, and you won't want to miss what we find next. Thanks for watching, and stay curious.